Hi, I'm Trevor Broussard, a senior solutions engineer at DroneDeploy. Now that we've captured images and other types of media, we've uploaded to DroneDeploy. DroneDeploy has processed those images into maps and models and posted the other types of media to the model. Now we can explore. You'll see I'm in the Explore tab. In the top left, we have the project name. Below the project name, we have the map selector. I can see that we have two maps captured in this project. One appears to be the overall flight. The other appears to be a short corridor flight over the practice fields. Below the map selector, we have the walk selector. We have one walk that was captured on November 29th, and I can see it's near the north side of the building around the perimeter. Below the walk selector, we have our layers. This project does not have any layers yet. Let's hit add. We can bring in various file types from the local device or from a number of integration partners. Commonly, we will see layers brought in from Autodesk or Procore. The most common layer type we see would be a drawing overlay. This can be uploaded as a PNG or a PDF. Some typical drawings I see uploaded would be a site plan, maybe a structural drawing. Maybe it could be an underground utility drawing. Bring them in, orient them on the site, and you can verify work that's in place, not in place, out of tolerance, and those sorts of things. We support other file types that can be uploaded, but we're just going to cover the most common drawings, 2D and 3D visualizations. These can be brought in via DXF or IFC. Also, we support design surfaces. Design surfaces are helpful for analyzing cut fill analysis. Let's say we bring in a design surface of the future state of the site, and we would like to compare the map, the existing map, to the future state. DroneDeploy can provide accurate numbers for cut fill analysis. We'll take a look at 2D and 3D visualizations at another point in the demo. Below the Layers tab, we have Map Analysis. If you click into the map title, you'll be brought into map details. We can change the map name, perhaps changing to a more accurate representation of what we are viewing. We'll leave it map plan for now. This map was captured on November 29th. There are 464 images. We can turn off the DroneDeploy generated orthomosaic or map. We can also turn off the adjacent satellite tile layer. This is the map that was generated in DroneDeploy. We have abilities to crop the map down. We can also calibrate the elevation. Let's say that we know a known point on site and we know the elevation. We would like to shift the entire map up or down. This is how we would do that. We recommend calibrating towards the center of the map. We have some more details below, such as orthomosaic resolution, if the map was aligned to a previous map. Some accuracy tags here, PPK, post-processing kinematics, RTK, real-time kinematics, GCPs, ground control points. And then we have checkpoints. Checkpoints are the way to really validate map accuracy. Here we're provided with the RMSE, the root mean square error. The RMSE of this map is 0.1 feet. The RMSE is the average of X, Y, and Z error. Looking below, we get some more details, but mainly what we come down to the bottom of map details to view is the type of drone that captured these images. And I usually look for the relative altitude. The drone flew roughly 200 feet above the surface. Under map analysis, we have some more details, such as plant health. Some of our agriculture customers will use the plant health feature to assess crop health. Cut fill. This project is not a good candidate for cut fill. We only have one overall site map and one corridor map. But with the cut fill tool, we can compare two maps in time or compare to the design surface to get accurate cut fill readouts. We display the elevation layer. We can also refine the histogram and slide the histogram. This is helpful for assessing drainage on site Maybe we're looking for high spots or low spots. This is the tool I would use. We also offer some terrain editing. Looking down to the media tab, this is how we organize all of the media. Firstly, we organize on the map view. Everything has a location, as well as we get more of the album view. We can look at walks. We can turn walks on and off. We can look at panos, photos, videos, vertical inspections, and then also turn on all the map photos. These are the raw images that make up the orthomosaic as well as the model. We also have a markups tab. This is where we can turn off any annotations that were generated in the map and model, as well as issues. If you have any apps installed, they will be displayed in the Apps and Integrations tab. Working our way to the right, we have a date range selector. This applies to all media aside from walks. Maybe we are only interested in the last 7 days or a custom date range. We have toggles for the interior and exterior. Currently, we are viewing the exterior. If we move to the interior, we need to upload drawings. Those can be uploaded from the local device or from a number of our integration partners. Working towards the right side, we can see that I'm an editor on this project. I also have the ability to share, as well as different permission types. I can also share view-only links for the whole project or an individual map. Looking more to the right, we have settings. We will come back to settings in just a little bit. Compare maps. This works really well for maps over time. Right now, we just have the small corridor map as well as the overall map of the site, but you can use the slider bar and move across the map. This works really well if we're looking for a month-to-month analysis. Maybe in one map, we have trenches that are open. The next map, trenches are backfilled, and we're looking for underground utilities. You can select different maps on either side. "3D models." You may hear 3D models sometimes referred to as meshes. Let's explore the model. We still have elevation details in the model. We can also display contour lines. We can adjust the major and minor line spacing as well. All of the raw photos are still displayed here in the model view. Same with annotations. On the right side, we can enable auto rotate and adjust the speed. We also have the camera animation feature. All we need to do is add another current position. I believe I've added some camera positions prior. Let's add another camera position. And now let's start animation. This is the nice way to create essentially a fly through of the site of the model. I like to use the inspect tool. It can be found uh, by clicking the magnifying glass next to the camera animation tool. The inspect tool works really well if you're looking for if you're looking for the raw image associated with the map or model. This provides a higher definition image that is not processed into a map or model. Something I like to highlight here is the ability to generate issues within the raw image. Perhaps there's an issue on the tennis courts I would like to highlight to my team. We can select a custom type, perhaps quality, safety, or maybe it's just a note for later follow-up. We can also associate a status, open or closed, a brief summary, as well as the severity level, and possibly a cost to repair. We can also send these issues and observations to Autodesk or Procore. I hit done, and now we can see that this issue lives within the context of the model. I know where the issue is. I can also click into the issue, and I can create comments. Something I like to highlight would be the ability to @mention others that are added to the project. If I do @mention Brian Vizaretta and provide some brief dialogue here, he will get an email notification directing him to this issue to eliminate some of the back and forth with communication of finding the same issue on site. Eventually, this issue should be closed. We also have some more options within the 3D. We can set the camera angle. We can reset the set camera angle, as well as some model rendering tools. We can turn on high definition, and we can also change the map and model opacity. This would be helpful if you choose to bring in 3D content as an IFC or 3D DXF. Maybe we're looking to verify installation of underground utilities, and we would like to see through the surface of where these utilities could possibly lie. Changing the model and map opacity would be helpful. We also have a view cube in the top right. Maybe we would like to navigate the project using the view cube. Let's go back into 2D. Now we're back into the 2D, or sometimes referred to as an orthomosaic. Let's explore some of the other annotation tools that we have access to. Point annotations. These are helpful for conveying the X, Y, and Z, or lat long, northing, easting, and elevation of a location on site. Any of these annotation types, we can create issues out of them. I recommend giving the annotation a name to stay organized. We can also change the color. We have some other annotation types to talk about. The line annotation. Let's demonstrate the accuracy of the line annotation on the football field. So I know that a football field is 100 yards or 300 feet. In DroneDeploy, we are calling the distance of the field without the end zones at 299.82 feet. We display some other information about the line, such as horizontal length, vertical length, surface length, cross-section slope, and vertical height. We also display the surface profile viewer. You'll see as I move my cursor down the line in the surface profile viewer that there's a node displayed on the line that was drawn on the field to give me an idea of where I am on the field and the elevation. We can display area. We can also draw various shapes such as rectangles and radiuses. I have a rectangle drawn here. We've got 20 yards, or let's see, we've got 29.9 horizontal length and 160.6 horizontal width. I use the circle tool or the radius tool demonstrated here on this baseball or softball field. One way I've seen this used in the past was to demonstrate the pick radius for a tower crane or really any sort of crane. I know that my crane can pick 100 feet out from the center. So using the radius tool, I can demonstrate the limits my crane can pick from. Any of these annotations, we have the ability to lock. We also have the ability to copy a link. We can also duplicate the annotation as well as delete. Some other annotation types, we give you the ability to count. Perhaps we're looking to count stored materials on site for billing purposes. Hit enter once you're done. Now we can see we have 6 items counted. We would like to give it a name and perhaps change the color. We give you the option to create a volume annotation as well. I demonstrated the volume annotation on the pitching mound of this baseball field. The way I found the toe of this pile was I turned on the elevation layer. I refined down to the elevation I'm looking for. Here, let's drop the point annotation. Around the pile, we can see that the elevation is 112.69. Now we can see precisely where the pitching mound is located. And I just used the volume tool to, to find the toe of the pile. I know that this pitching mound, there's material volume of 3.72 cubic yards. I also get the area. I get some cut fill stats as well as the net volume. If I wanted to, I can input a material density as well as the cost associated, and we can give you more information of the material in this pile. Selecting the surface type as well as the base plane would be very helpful for accurate volume calculations. You can get more information here by clicking the question mark and clicking on read more to learn more about base planes. We can generate issues just like we did in raw images. We can also generate point or area issues, perhaps for tracking purposes. Change the title, give it a type, a status, a summary, severity, cost of repair. Manage this issue or observation in Autodesk or Procore, or have dialogue with colleagues here within the issue. Looking down to the bottom right, you have options for zooming in and out, as well as rotating the map around. Zooming back out to look at the media gallery, we briefly touched on some of our media types. We have 3 walks, which we will look at. We have 1 pano. I can see 1 pano here in the media gallery, as well as on site. This is the nice 26 frame pano that's stitched together. It's a high definition pano. If we have other panos that were captured in the same rough location, we could compare side by side. We also have options to see who captured the pano and what was the date, delete, renaming the media, and moving the media. We can also download this pano, share a link, and if we had other panos captured in the same rough location, we would have options to view the media gallery for other adjacent panos. All of this media were given the context of the mini map. And now we're going to back out. We also have photos. These are oftentimes used as progress updates. Videos. And we have vertical inspections. I can see that there is the vertical inspection icon here at the north face of this building. Vertical inspections work a lot like models in terms of navigation. I typically will use a vertical inspection to visually inspect various components on the exterior of a building, tower, bridge, dam, or similar. I use the inspect tool to find raw images for a higher definition. I use the inspect tool when I'm inspecting for various components on the exterior of a building. I would like to find the raw images. I can use the keys on my keyboard to navigate around and perform visual inspections. If at any point I notice something that I would like to document, I can use the issues tool, just like we did on the exterior. in the maps and models. I can do the same on a facade inspection. This issue will live within the context of the 3D facade scan. Lastly, let's look at some export types. In the bottom left corner of the screen, you'll find the export button. We'll go through some of the most commonly used export types. These are all manual exports, but if we would like to set up auto exports, that's an option as well. PDF maps, GeoTIFF or georeferenced maps. My favorite export type to export a map would be the JPEG map. The reason why is within a JPEG map, I can select the resolution. Some other export types most commonly used would be our point clouds. I particularly like that our point clouds we can decimate. We also have some file type options available. Most commonly I see RCP exports. We also support XYZ as well as LAS. Elevation details. And there's a number of file types that we can export. Commonly I'll see a DXF with contour lines. We also support raw elevation values as a DEM. Digital terrain models, cut fill DSMs, cut fill DTMs. These are helpful for assessing cut fill over time. 3D models, we can export out an OBJ of the 3D model. Roof analysis and plant health, not commonly used in building applications, but they're available, as well as edge annotations. We also support source data exports. This source data export is per map, and it's for the mapping photos.